There's a place in the universe where stars are born inside towering pillars of gas that stretch for light years, painted in colors our eyes could never see without help from space telescopes. Another region where two galaxies dance together in a cosmic ballet that will last for millions of years, their spiral arms reaching toward each other like celestial lovers. And somewhere else, a dying star has created a butterfly made of light, so perfect and symmetrical that it seems impossible nature could sculpt something so delicate from such violent forces. Today, we're embarking on a visual journey through the most breathtaking, awe-inspiring, and beautiful objects our universe has created. And what makes them even more extraordinary is that you, sitting there right now, are made from the same stardust that forms these cosmic masterpieces. If you're captivated by the universe's incredible beauty and want to explore more cosmic wonders, make sure to subscribe to this channel and give a thumbs up. Now let's begin this journey. Let's start with one of the most iconic and stunning objects ever photographed by the Hubble Space Telescope, the Pillars of Creation. Located about 7,000 light-years away in the Eagle Nebula, these towering columns of interstellar gas and dust stand like cosmic monuments, reaching heights of 4 to 5 light-years. That's nearly 47 trillion kilometers tall. But their beauty isn't just in their size, it's in what they represent. These pillars are stellar nurseries, places where gravity is right now sculpting new stars from the raw materials of space. When Hubble first captured these pillars in 1995, the image changed how humanity sees the universe. The photograph revealed intricate details, wispy tendrils of gas being blown away by stellar winds, dark globules where baby stars are forming, and an ethereal glow that makes the entire structure look alive. In 2014, Hubble revisited the pillars with upgraded instruments, capturing them in near-infrared light. This revealed stars hidden inside the pillars, invisible to optical telescopes but glowing brilliantly in infrared. It's like having X-ray vision that lets us see stellar embryos still wrapped in their cosmic cocoons. The colors in these images aren't arbitrary, they represent different elements and temperatures. The green hues come from hydrogen, the red from sulfur, and the blue from oxygen. These elements, forged in the hearts of earlier generations of stars, are being recycled into new stellar systems. Some of those nascent stars probably have planets forming around them right now. In a very real sense, we're looking at solar systems being born, possibly worlds where, billions of years from now, beings might look up at their night sky and wonder about their origins, just as we do. But here's something that adds poignancy to their beauty. The pillars of creation may already be gone. Observations from the Spitzer Space Telescope suggest a supernova explosion near the pillars about 6,000 years ago. The shockwave from that explosion would have destroyed the pillars, but because light takes 7,000 years to reach us from the Eagle Nebula, we might be admiring a cosmic monument that no longer exists. We're seeing the past, preserved in light, witnessing beauty that time has already claimed. Moving from stellar birth to stellar death, let's explore the Helix Nebula, often called the Eye of God. Located about 650 light-years away in the constellation Aquarius, this planetary nebula showcases what our own Sun will look like in about 5 billion years. Despite its name, it has nothing to do with planets. Early astronomers called them planetary nebulae because through their small telescopes, these objects looked round like planets. We now know they're the expelled outer layers of dying stars. The Helix Nebula spans about 2.5 light-years across, making it one of the largest and closest planetary nebulae to Earth. Its structure is far more complex than it initially appears. What looks like a simple ring is actually a 3-dimensional helix structure. Imagine looking down a massive cosmic spring. The inner region glows with temperatures exceeding 120,000 degrees Celsius, hot enough to emit intense ultraviolet radiation that lights up the surrounding gas like a neon sign. Recent observations from the James Webb Space Telescope have revealed incredible details within the Helix. Thousands of cometary knots, each about the size of our solar system, radiate outward from the center like cosmic tadpoles. These knots are denser clumps of gas and dust that have somehow survived the star's violent expulsion of its outer layers. Each one contains enough material to form planets, but they're slowly evaporating under the intense radiation from the white dwarf at the nebula's heart. The colors tell the story of chemical elements scattered through space. The blue-green center comes from oxygen atoms stripped of electrons by the intense radiation. The red outer regions glow from nitrogen and hydrogen. These elements will eventually drift into space, perhaps to be incorporated into new stars and planets millions of years from now. When astronomers say we're made of stardust, this is exactly what they mean. The calcium in your bones, the iron in your blood, the carbon in your DNA all came from stars that died like this, spreading their enriched guts across space. Now let's journey to Messier 51, better known as the Whirlpool Galaxy, one of the most perfectly formed spiral galaxies we've ever observed. Located about 23 million light-years away, this grand design spiral galaxy is interacting with a smaller companion, Galaxy NGC 5195. This cosmic dance has been going on for hundreds of millions of years, and it's created one of the most photogenic galaxies in our night sky. The Whirlpool Galaxy's spiral arms are so prominent because of the gravitational interaction with its companion. As the smaller galaxy passes by, its gravity creates density waves that ripple through the whirlpool's disk. These waves compress gas and dust, triggering intense star formation. The bright blue regions along the spiral arms are clusters of hot, young stars, born from this gravitational disturbance. The darker dust lanes that trace the spiral pattern are the raw material for future generations of stars. What makes the whirlpool particularly special for astronomers is that we see it face on, giving us a perfect view of its spiral structure. This orientation has allowed us to study how spiral arms form and evolve, how stars migrate through galactic disks, and how smaller galaxies can reshape larger ones through gravitational interaction. Every detailed observation teaches us more about our own Milky Way, which we can never see from the outside. The Hubble Space Telescope has observed the Whirlpool Galaxy multiple times over decades, and these observations have revealed something remarkable. We can actually see individual stars exploding as supernovae. In 2011, astronomers captured a star in its final death throes, watching as it brightened to billions of times its normal luminosity before fading away. Think about that for a moment. We watched a single star die in a galaxy 23 million light-years away. The light from that explosion traveled for 23 million years just to reach our telescopes, carrying the story of that star's final moments across the cosmic void. Speaking of extraordinary cosmic phenomena, if you're fascinated by the universe's extremes, check out my video, The Rarest Object in the Universe, where we explore cosmic unicorns that shouldn't exist but do. The link is in the description below. Now let's continue our journey through cosmic beauty. Let's venture to Saturn, where nature has created something that seems to violate the laws of geometry, a perfect hexagon at the planet's north pole. This isn't a subtle feature you need special equipment to see. It's a massive six-sided storm system that's been raging for at least 40 years, possibly much longer. Each side of this hexagon stretches about 13,800 kilometers. That's wider than Earth's entire diameter. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, gave us our best views of this bizarre and beautiful phenomenon. The hexagon isn't just a cloud pattern, it's a jet stream, a river of air flowing at about 320 kilometers per hour. But unlike Earth's meandering jet streams, Saturn's maintains this perfect geometric shape. Scientists have recreated similar patterns in laboratory experiments using rotating fluids, but seeing it occur naturally on such a massive scale is mind-blowing. The hexagon extends deep into Saturn's atmosphere, at least 300 kilometers down, and it changes color with Saturn's seasons, shifting from blue to golden as the North Pole emerged from its 7-year winter into sunlight. At the very center of the hexagon sits another marvel, a massive hurricane with an eye 2,000 kilometers wide, spinning at speeds exceeding 530 kilometers per hour. The Cassini spacecraft captured this storm in unprecedented detail, revealing cloud walls towering 60 kilometers high, about 20 times taller than Earth's hurricanes. The entire structure looks like something an artist might create, not a natural phenomenon. Yet there it is, a perfect piece of cosmic geometry crowned with a violent storm, all painted in Saturn's subtle butterscotch hues. Moving from geometric precision to organic beauty, let's explore NGC 6302, better known as the Bug Nebula or Butterfly Nebula. This planetary nebula in the constellation Scorpius showcases what happens when a dying star doesn't go gentle into that cosmic night. The central star, hidden within a dense disk of gas and dust, has a surface temperature exceeding 200,000 degrees Celsius, about 36 times hotter than our Sun's surface. This extreme heat has sculpted the expelled gas into wings that stretch over 3 light-years from tip to tip. The Butterfly Nebula is one of the most complex planetary nebulae we've discovered. High-resolution images from Hubble reveal intricate structures within the wings, knots, jets, and shells that tell the story of multiple explosive events. The star didn't just puff off its outer layers once, it went through several violent episodes, each one shaping the nebula we see today. The wings aren't actually solid structures, but hollow bubbles of superheated gas expanding at over 600 kilometers per second. What makes this nebula particularly stunning are the colors created by different elements at various temperatures. The edges glow red from nitrogen, while the interior shows green from oxygen and blue from helium. Iron, rarely visible in planetary nebulae, creates orange knots throughout the structure. These iron emissions tell us the original star was particularly massive for a planetary nebula progenitor, probably over 5 times the Sun's mass. The result is a cosmic butterfly with wings of fire, frozen in a moment of explosive transformation. Now let's witness one of the universe's most violent events, frozen in a moment of devastating beauty, the Crab Nebula. On July 4th, 1054, Chinese astronomers recorded a guest star in the constellation Taurus, visible even during daylight for 23 days. Native American petroglyphs might also record this same event. What they witnessed was a massive star destroying itself in a supernova explosion, and what remains today is one of the most studied and photographed objects in astronomy. The Crab Nebula spans about 11 light-years across and is expanding at 1,500 kilometers per second. But its beauty isn't just in its filamentary structure that resembles a cosmic chrysanthemum. At its heart spins a pulsar, a neutron star only about 20 kilometers across, but containing more mass than our Sun, rotating 30 times per second. This cosmic lighthouse sends out beams of radiation that we detect as regular pulses, hence the name Pulsar. The energy from this spinning stellar corpse lights up the entire nebula, making it glow across the electromagnetic spectrum from radio waves to gamma rays. The filaments we see aren't static, they're constantly moving and changing. By comparing photographs taken years apart, astronomers can actually watch the nebula expand in real time, cosmic motion visible within human lifetimes. The outer filaments, glowing red from hydrogen, are remnants of the star's outer layers. The bluish-white glow filling the interior is synchrotron radiation, electrons spiraling through magnetic fields at nearly the speed of light. It's particle physics on a nebula scale, a natural particle accelerator more powerful than anything humans could build. Recent observations from the James Webb Space Telescope have revealed new details in infrared light, showing dust grains being formed in the nebula. This is cosmic recycling in action. A star that died nearly 1,000 years ago is creating the raw materials for future planets and possibly life. Some of the molecules detected in the Crab Nebula are organic compounds, the building blocks of biology. Death and birth, destruction and creation, all wrapped up in filaments of glowing gas that happen to be heartbreakingly beautiful. Let's journey now to the large Magellanic Cloud, one of our nearest galactic neighbors at 160,000 light-years away, where we find the Tarantula Nebula, the largest and most violent star-forming region in our local group of galaxies. Also known as 30 Doradus, this stellar nursery is about 1,000 light-years across. If it were as close to Earth as the Orion Nebula, it would cover half our sky and cast shadows at night. The Tarantula Nebula is a cosmic factory operating at maximum capacity. Within its glowing clouds, stars are being born at a rate unlike anywhere else we can observe up close. At its heart lies R136, a star cluster so massive and bright that astronomers initially thought it was a single star. We now know it contains over 200 massive stars, including some of the most massive stars ever discovered, giants exceeding 200 times the mass of our Sun. These stellar monsters live fast and die young, burning through their nuclear fuel in just a few million years instead of billions like our Sun. The nebula gets its name from its appearance in telescopes, sprawling filaments of gas that resemble spider legs stretching across space. But these legs are actually cavities, blown in the surrounding gas by fierce stellar winds and supernovae. The central region has been carved hollow by the combined radiation of thousands of hot young stars, creating a bubble hundreds of light-years across. The walls of this bubble glow in brilliant reds and pinks from hydrogen, while patches of green reveal oxygen heated to tens of thousands of degrees. In 2022, the James Webb Space Telescope turned its infrared eye toward the Tarantula and revealed something extraordinary: tens of thousands of young stars that were hidden behind veils of cosmic dust. Some of these stars are still wrapped in the cocoons from which they formed, their light just beginning to break free. Webb also captured protostars in the act of formation, gathering material from their surroundings through glowing jets and disks. We're literally watching stellar birth in real time, seeing processes that will eventually create planetary systems like our own. The Tarantula Nebula holds special significance because its chemical composition is similar to that of star-forming regions in the early universe, when heavier elements were much rarer. By studying the Tarantula, we're glimpsing what star formation looked like billions of years ago when galaxies were young and the universe was a more violent, dynamic place. It's a window into our cosmic past, wrapped in gossamer veils of glowing gas. From stellar nurseries, let's shift to one of the most perfect examples of cosmic symmetry, the Cat's Eye Nebula, officially known as NGC 6543. Located 3,300 light-years away in the constellation Draco, this planetary nebula displays a complexity that astronomers are still trying to fully understand. When William Herschel discovered it in 1786, he thought it looked like a planet. Modern telescopes reveal it to be something far more extraordinary, a series of concentric shells, knots, and jets that create an almost hypnotic pattern. The structure of the cat's eye is like a cosmic onion, with at least 11 distinct shells of gas surrounding the central star. These shells tell us that the dying star didn't expel its outer layers in one event but in a series of pulses, each occurring about every 1,500 years. The spacing is so regular it's like looking at tree rings, but instead of recording seasons, these rings record the death throes of a star. Between the shells, we see knots of denser material, each one containing as much mass as Earth, but glowing at temperatures exceeding 10,000 degrees Celsius. What makes the cat's eye particularly mesmerizing is its color palette. The central region glows blue-green from highly ionized oxygen, surrounded by a red halo of hydrogen and nitrogen. But Hubble's images reveal subtle color variations throughout purples, yellows, and whites that represent different elements at different temperatures and ionization states. It's like a cosmic aurora painted not by Earth's magnetic field, but by a dying star's last breath. The most puzzling feature of the cat's eye is its bipolar symmetry combined with its circular shells. This suggests the central star might have a companion, their orbital dance influencing how the gas was expelled. X-ray observations from the Chandra Space Observatory revealed superhot gas at the nebula's center, heated to millions of degrees by shock waves as fast-moving gas slams into slower material. This violent collision creates the intricate structures we see, beauty born from stellar violence. Now let me take you to something that challenges our very notion of what galaxies can be. Hoag's object, a ring galaxy located 600 million light-years away in the constellation Serpens. Discovered by astronomer Art Hoag in 1950, this galaxy is one of the most perfectly symmetrical objects in the known universe. Picture a golden nucleus of older stars, surrounded by absolute darkness, then encircled by a perfect ring of young blue stars. It's as if someone took a normal galaxy and carefully removed everything between the center and the edge. Hoag's object spans about 120,000 light-years, slightly larger than our Milky Way, but its structure is unlike anything else. The gap between the central core and the ring is so clean, so empty, that you can see distant galaxies through it. In fact, if you look carefully at Hubble's images, you can spot another ring galaxy visible through the gap, a cosmic coincidence that astronomers calculate should be incredibly rare. It's like looking through one perfect circle to see another perfect circle billions of light years behind it. How such a perfect ring forms remains controversial. One theory suggests a collision billions of years ago where a smaller galaxy punched through the center of a larger one, sending ripples outward like drops in a cosmic pond. Another possibility is that the ring formed from the accretion of gas from a cosmic near-miss, where two galaxies passed close enough to distort each other but not merge. The most intriguing theory suggests Hoag's object formed naturally through unusual gravitational resonances, making it not the product of violence but of cosmic harmony. The ring itself is a hotbed of star formation, blazing with the blue light of massive young stars. These stars are probably less than 2 billion years old, infants by cosmic standards, while the central core contains stars over 10 billion years old. It's like finding a nursery surrounding a retirement home, with nothing in between. Spectroscopic analysis reveals the ring is expanding outward at about 75 kilometers per second, suggesting whatever created this structure is still influencing its evolution. Let's explore something that seems to defy physics at first glance: the Boomerang Nebula, the coldest known place in the universe outside of laboratories. Located 5,000 light-years away in the constellation Centaurus, this young planetary nebula has a temperature of just 1 degree Kelvin, that's minus 272 degrees Celsius, colder than the cosmic microwave background radiation that fills empty space. It's literally colder than empty space itself, a phenomenon that seems impossible until you understand the physics involved. The Boomerang Nebula achieved this record-breaking cold through rapid expansion. As the dying star expelled its outer layers at nearly 164 kilometers per second, about 10 times faster than typical planetary nebulae, the gas underwent extreme adiabatic expansion. It's the same principle that makes spray cans feel cold, but taken to a cosmic extreme. The expanding gas is cooling so rapidly that it's actually absorbing the cosmic microwave background radiation rather than emitting energy, creating a shadow in the universe's background glow. Visually, the Boomerang Nebula looks nothing like its namesake. Recent observations from ALMA, the Atacama Large Millimeter Array, revealed its true shape, more like a ghostly bow tie or butterfly with overlapping wings. The central star is hidden behind a thick lane of dust, but its effects are visible everywhere. The nebula glows with an eerie blue light, not from heat, but from starlight reflecting off dust grains. It's like looking at moonlight on fresh snow, beautiful but cold, ethereal but lifeless. What makes the Boomerang particularly fascinating is that it's showing us a brief phase in stellar evolution that lasts only about 1,500 years. In cosmic terms, that's a blink of an eye. We're incredibly fortunate to witness this object during its record-breaking cold phase. Soon, astronomically speaking, the expansion will slow, the gas will warm, and the Boomerang will become just another planetary nebula. We're seeing a cosmic moment that's both beautiful and scientifically precious, a natural experiment in extreme physics. Now let's witness one of the most colorful and dynamic regions in our galaxy, the Carina Nebula, home to some of the most massive and luminous stars known. Located 7,500 light-years away, this stellar nursery spans over 300 light-years, making it one of the largest star-forming regions in the Milky Way. But size alone doesn't capture its magnificence. The Carina Nebula is a three-dimensional sculpture of gas and dust, carved by stellar winds and radiation into fantastic shapes that boggle the imagination. The most famous feature within Carina is the Mystic Mountain, a 3 light-year tall pillar of gas and dust that looks like a cosmic skyscraper. Captured by Hubble for its 20th anniversary, this tower is being eroded by the intense radiation from nearby stars, creating streamers of gas that flow off its peaks like waterfalls of light. Jets of material shoot from infant stars hidden within, extending half a light-year into space. The entire structure glows in yellows and oranges from sulfur, greens from hydrogen, and blues from oxygen, creating a palette that would make any artist envious. At the heart of the Carina Nebula lies Eta Carinae, one of the most massive and unstable stars in our galaxy. This stellar monster, about 100 times the mass of our Sun, suffered a great eruption. In 1843, suddenly becoming the second brightest star in Earth's sky before fading. That eruption created the distinctive homunculus nebula, 2 mushroom-shaped lobes of gas expanding outward at 600 kilometers per second. Eta Carinae is a ticking time bomb destined to explode as a hypernova possibly within the next million years, though it could happen tomorrow. Recent infrared observations from James Webb have penetrated the thick dust clouds of the Carina Nebula, revealing hundreds of jets and outflows from forming stars. These cosmic fountains, some stretching light-years in length, mark the birth cries of new solar systems. Webb also captured the cosmic cliffs, a wall of gas and dust 7 light-years high that looks remarkably like a mountain range at sunset. But this sunset is painted in infrared light, revealing baby stars emerging from their dusty cocoons like butterflies from chrysalises. Let's journey to one of the most controversial and beautiful objects discovered by Hubble, the Red Rectangle Nebula. Located about 2,300 light-years away in the constellation Monopteros, this protoplanetary nebula displays a geometric precision that seems almost artificial. It's a perfect X or cross shape, with ladder-like rungs crossing the arms, all glowing in deep reds and oranges. When first discovered, some astronomers couldn't believe it was natural. The red rectangle's unusual shape comes from a binary star system at its center, where one star is dying and transferring material to its companion. This creates a thick disk of dust around the star's equator, which blocks light in those directions. We only see light escaping from the poles, creating the X shape. But the ladder rungs remained a mystery until scientists realized they're actually a series of nested biconical shells viewed edge-on. Every few hundred years, the dying star experiences an outburst, creating a new shell. We're looking at a cosmic history book, each rung recording an episode in the star's death. What makes the red rectangle particularly special is its color, which comes from unique carbon-rich molecules called polycyclic aromatic hydrocarbons, the same compounds found in car exhaust and burnt toast, but here creating cosmic art. These molecules fluoresce in red light when excited by ultraviolet radiation from the central stars. Some scientists believe these compounds might be precursors to life, making the red rectangle not just beautiful, but potentially important for understanding how organic chemistry begins in space. Moving to the far southern sky, let's explore NGC 3576, better known as the Statue of Liberty Nebula, though some see it as a cosmic angel. This star-forming region in the Carina constellation showcases triggered star formation, where the death of one generation of stars causes the birth of the next. Massive stars that formed millions of years ago have carved a cavity in the surrounding gas, and now, along the edges of this cavity, a new generation of stars is being born. The nebula gets its nickname from a distinctive pillar of gas that resembles an arm holding up a torch, or a wing stretched toward heaven, depending on your perspective. This pillar is about 3 light-years tall, composed of cold molecular hydrogen that's dense enough to resist the stellar winds trying to blow it away, but it won't last forever. In perhaps 100,000 years, the pillar will be eroded completely, its material either forming new stars or dispersing into space. Within the Statue of Liberty Nebula, infrared observations have revealed over 30 young stellar objects still wrapped in their birth cocoons. Some of these protostars are shooting bipolar jets that extend for light years, carving tunnels through the surrounding gas. These jets rotate like cosmic sprinklers, their direction changing over thousands of years as the young stars wobble on their axes. The result is a corkscrew pattern of shocked gas that glows in greens and blues, adding detail to the nebula's already complex structure. Now let me show you something that redefines our understanding of galactic beauty, NGC 1300, known as the Toothbrush Galaxy. Located about 230 million light-years away, this isn't actually a galaxy but a massive galaxy cluster collision, one of the most energetic events in the universe. The Toothbrush is a radio relic, a shock wave 6 million light-years long where particles are accelerated to nearly the speed of light, creating a structure that glows brilliantly in radio wavelengths but is invisible to optical telescopes. When we combine radio observations with X-ray data from Chandra and optical images from ground-based telescopes, we see a cosmic catastrophe of unimaginable scale. 2 galaxy clusters, each containing hundreds of galaxies and weighing quadrillions of times our Sun's mass, are smashing together at speeds of millions of kilometers per hour. The collision heats gas to over 100 million degrees, creating a glowing cloud of X-rays larger than our entire local group of galaxies. It's destruction and creation on a scale that makes our earthly concerns seem infinitesimally small. But here's what makes it beautiful beyond its violence. The collision is creating new structures that will last billions of years. Galaxies are being stripped of their gas, which streams behind them like cosmic hair in a stellar wind. Dark matter is separating from normal matter, revealing itself through gravitational lensing. And at the shock fronts, cosmic rays are being accelerated to energies we can barely comprehend. We're witnessing the universe rebuilding itself, transforming two clusters into something new, something that wouldn't exist without this violent encounter. Let's shift from cosmic violence to serene beauty with Messier 57, the Ring Nebula, one of the most photographed objects in the night sky. Located about 2,300 light-years away in the constellation Lyra, this planetary nebula looks like a perfect smoke ring blown by a cosmic giant. For centuries, astronomers thought we were looking at a simple shell of gas. Modern observations reveal something far more complex and beautiful. The Ring Nebula isn't actually a ring, but a barrel-shaped structure that we happen to be viewing almost down its axis. Imagine looking through a jelly donut from one end. You see the hole clearly, surrounded by the dough. The ring we see is about 1 light-year across, expanding at 20 kilometers per second. At its center sits a white dwarf, the compressed core of the star that created this structure about 4,000 years ago. This stellar remnant, now Earth-sized but with the Sun's mass, has a surface temperature of 120,000 degrees Celsius. Recent images from the James Webb Space Telescope transformed our understanding of the Ring Nebula. Webb revealed intricate details invisible to previous telescopes, thousands of dense clumps in the ring, each containing as much mass as Earth. These clumps glow like jewels, each one a potential seed for future cosmic structures. Webb also showed us the nebula's outer halo for the first time, concentric shells of gas extending far beyond the visible ring, recording 10,000 years of the star's death process. The colors are extraordinary: deep reds from nitrogen, emerald greens from oxygen, and blues from helium, all painting a portrait of stellar transformation. Now let me take you to a place where nature creates perfect spirals on a galactic scale, Messier 74, the Phantom Galaxy. Located 32 million light-years away, this grand design spiral galaxy presents itself face-on to Earth, giving us an unobstructed view of its magnificent spiral structure. Its arms sweep out from the center in perfect logarithmic spirals, following mathematical curves that appear throughout nature, from nautilus shells to hurricanes. The Phantom Galaxy earned its ghostly name from being difficult to observe with small telescopes. Its surface brightness is low, making it appear as a faint spectre. But when captured by large telescopes, especially in different wavelengths, it reveals stunning beauty. The spiral arms are traced by dark dust lanes and bright blue star clusters, with pink hydrogen regions marking stellar nurseries. It's like looking at a cosmic flower with petals made of billions of stars. In 2022, the James Webb Space Telescope captured the Phantom Galaxy in infrared, revealing its skeleton, the underlying structure usually hidden by dust. Webb showed us the galaxy's bones, filaments of gas feeding the spiral arms, hidden star clusters, and the precise gravitational pathways that maintain the spiral pattern. When astronomers combined Webb's infrared data with Hubble's optical observations, they created images of unprecedented beauty and scientific value. The galaxy appears three-dimensional, with layers of structure visible from the nuclear star cluster to the outer spiral arms. Let's witness one of the most beautiful stellar deaths ever recorded, the Eskimo Nebula, also known as NGC 2392. Located 3,000 light-years away, this planetary nebula resembles a face surrounded by a fur-lined Parker hood when viewed through telescopes. But high-resolution images reveal something far more intricate, a double shell structure that tells the story of a star's complex death. The inner shell, about half a light-year across, glows with the fierce blue-green light of doubly ionized oxygen heated to 10,000 degrees. This shell is expanding at about 120 kilometers per second, plowing through space like a cosmic snowplow. The outer shell, nearly a light-year across, consists of material expelled earlier in the star's death process. Between these shells, we see remarkable structures, radial filaments that stretch from the inner to outer shell like spokes on a wheel, and dense knots of gas that somehow survived the stellar wind. What makes the Eskimo Nebula particularly stunning is its asymmetry disguised as symmetry. At first glance, it appears perfectly round, but detailed analysis reveals complex structures. Orange filaments of nitrogen streak across the nebula's face. Comet-like tails stream from dense knots as stellar wind erodes them. The central star, now a white dwarf, creates a cavity in the inner nebula with its fierce radiation. X-ray observations show million-degree gas where the fast wind crashes into slower-moving material. It's organized chaos, violence creating beauty. Moving to one of the southern sky's crown jewels, let's explore NGC 3372, better known as the Homunculus Nebula surrounding Eta Carinae. This bipolar nebula was created during the Great Eruption of 1843, when Eta Carinae suddenly expelled about 10 solar masses of material. The result is a peanut-shaped nebula about half a light-year long, expanding at 600 kilometers per second, glowing with the light of one of the galaxy's most extreme stars. The Homunculus Nebula is unlike any other structure we've observed. Its two lobes are nearly perfect mirror images, suggesting the eruption was surprisingly symmetrical despite its violence. Each lobe is hollow, like two balloons touching at their necks, with walls of gas and dust that glow in different colors depending on the wavelength observed. In visible light, it appears orange from nitrogen. In infrared, we see through the dust to the violent stellar wind inside. In X-rays, we witness million-degree shockwaves where different gas flows collide. But the homunculus holds mysteries within mysteries. Inside the larger structure, there's a little homunculus, a smaller, younger bipolar nebula, oriented differently from its parent. This suggests Eta Carinae had another eruption we didn't witness, perhaps centuries before the Great Eruption. Even more puzzling are the strings of gas that connect various parts of the nebula, defying simple models of how such structures should evolve. Some astronomers think we're seeing magnetic fields made visible by the gas they trap, cosmic field lines drawn in light. Eta Carinae itself remains one of the most extreme stars known. It's actually a binary system, two massive stars orbiting each other every 5.5 years. The primary star is about 100 solar masses and millions of times more luminous than our Sun. It's so bright that radiation pressure from its own light is literally tearing it apart. The secondary, only 30 times the Sun's mass, creates its own powerful stellar wind. Where these winds collide, they create X-rays detectable from Earth. We're watching stellar giants locked in a death spiral that will end with one or both exploding as supernovae. Now let's journey to a place where galaxy collisions create art, the Antennae galaxies NGC 4038 and 4039. Located 45 million light-years away, these two spiral galaxies have been dancing together for hundreds of millions of years, and their interaction has pulled out two long tidal tails that give them their insect-like appearance. But the real beauty lies in what this collision has triggered, the most intense burst of star formation we can observe in the nearby universe. Within the Antennae galaxies, over 1,000 bright star clusters have formed from the collision, some containing millions of young blue stars. These superstar clusters glow like diamonds scattered across the twisted spiral arms. Many are so young, less than 10 million years old, that they're still wrapped in the hydrogen gas from which they formed, creating pink bubbles throughout the merging galaxies. Some astronomers believe we're seeing globular clusters being born, the same type of ancient star clusters that orbit our Milky Way. The collision has created structures impossible in isolated galaxies. Bridges of stars and gas connect the two galactic cores. Shells of stars have been thrown out in graceful arcs. Dark dust lanes twist in impossible spirals as the galaxy's rotation becomes chaotic. And throughout this cosmic maelstrom, supernovae explode at a rate of several per year, each one briefly outshining billions of stars. The Hubble Space Telescope has been monitoring the antennae for decades, actually watching individual star clusters evolve and massive stars die. Let's explore one of the most perfectly sculpted planetary nebulae known, the Saturn Nebula, NGC 7009. Located 5,000 light-years away in Aquarius, this nebula gets its name from its resemblance to the planet Saturn when viewed edge-on through small telescopes. But high-resolution images reveal something far more complex than a simple disk. A series of nested shells, mysterious Antennae, handle-like projections, and high-speed jets that have puzzled astronomers for decades. The Saturn Nebula's central structure spans about half a light-year, but its influence extends much farther. Radio observations have detected a massive halo of cool gas extending 3 light-years from the center, material expelled long before the current visible nebula formed. The main body glows green from oxygen, while the Antennae shine pink from nitrogen and hydrogen. These handles extend from opposite sides of the nebula, perfectly aligned as if drawn with a cosmic ruler, but we still don't fully understand what creates and maintains them. Recent observations have revealed the Saturn Nebula is far more dynamic than its serene appearance suggests. High-speed knots of gas are shooting outward at over 300 kilometers per second. The central star, now a white dwarf, has a temperature exceeding 55,000 degrees Celsius and emits intense ultraviolet radiation that ionizes gas throughout the nebula. Some regions of the nebula are so hot they emit X-rays. We're not just looking at a pretty picture, we're witnessing the violent transformation of a star system frozen in a moment of terrible beauty. Now let me show you something that challenges our concepts of size and structure, the Rosette Nebula NGC 2237. Located 5,200 light-years away in the constellation Monoxeros, this emission nebula spans 130 light-years, so large that the Moon would appear smaller than just the central cavity. The nebula resembles its floral namesake, with petals of glowing gas surrounding a central void, all painted in the deep reds of hydrogen emission. The Rosette Nebula is sculpted by the very stars it created. At its center lies NGC 2244, a cluster of hot, young stars formed from the nebula's gas about 4 million years ago. These stellar children are now destroying their birthplace. Their combined stellar winds have blown a cavity 50 light-years wide in the center of the nebula. Their ultraviolet radiation ionizes the surrounding gas, making it glow, and their eventual deaths as supernovae will completely disperse the remaining gas, ending the nebula's star-forming career. What makes the Rosette particularly beautiful is its variety of structures at different scales. Elephant trunk pillars point toward the central cluster like fingers reaching for the stars that are destroying them. Dark globules, future stellar systems, dot the nebula like seeds. Shock fronts where stellar wind meets dense gas create glowing rims that outline fantastic shapes. Some astronomers see skulls, others see faces or animals in these random patterns. The human brain's pattern recognition turns cosmic chaos into familiar forms, making the Rosette a celestial Rorschach test. let's witness one of the most violent and beautiful events in the local universe, the cigar galaxy, Messier 82, caught in the midst of a starburst. Located 12 million light-years away, this galaxy is experiencing star formation at 10 times the rate of the Milky Way. But this isn't happening peacefully. The intense star formation is driving a galactic superwind, a fountain of gas and dust erupting from the galaxy's core, extending over 30,000 light-years into space. The cigar galaxy's dramatic appearance comes from its gravitational interaction with its larger neighbor, Messier 81. This cosmic harassment has compressed gas in M82's core, triggering the formation of millions of stars in a region just 5,000 light-years across. These young stars live fast and die young, with supernovae exploding every decade or so. The combined stellar winds and supernova explosions have created the spectacular bipolar outflow we see, a galactic fountain of superheated gas glowing in X-rays and studded with clumps of cooler gas that glow red in visible light. Infrared observations from the Spitzer and James Webb Space Telescopes reveal the true scale of destruction and creation. The galaxy's disk is riddled with over 200 star clusters, some less than 1 million years old. Polycyclic aromatic hydrocarbons, complex carbon molecules that might be precursors to life, are being blasted into intergalactic space by the superwind. We're watching a galaxy literally blow its guts out, seeding the surrounding space with the elements necessary for future generations of stars and possibly life. What makes the cigar galaxy particularly stunning in images is the contrast between its bright yellow-white core and the red filaments of the superwind. These filaments stretch like cosmic smoke from a stellar fire, following magnetic field lines that extend far beyond the visible galaxy. Some of this expelled gas will fall back onto the galaxy, triggering future star formation. Some will escape forever, enriching the intergalactic medium. It's a cosmic recycling system operating at a galactic scale, beautiful in its violence. Moving from galactic violence to stellar serenity, let's explore the bubble nebula NGC 7635, where a single star has blown a nearly perfect sphere in space. Located 7,000 light-years away in Cassiopeia, this nebula showcases what happens when an extremely hot star pushes against the surrounding interstellar medium. The star responsible, SAO 20444, is 45 times our Sun's mass and hundreds of thousands of times more luminous. The bubble itself is 7 light-years across, nearly twice the distance from our Sun to the nearest star. But it's not centered on the star that created it. The star sits closer to one edge because it's pushing against denser gas in that direction. The bubble glows because the star's intense ultraviolet radiation ionizes its inner surface. Different regions glow different colors depending on their composition and temperature: blue from oxygen, green from hydrogen, red from nitrogen and sulfur. It's like a cosmic soap bubble, but one that would take light 7 years to cross. The bubble nebula is still growing, expanding at about 20 kilometers per second. In another 1 million years, it will likely merge with other bubbles being blown by nearby stars, creating a superbubble hundreds of light-years across. These superbubbles are important for galaxy evolution. They're how heavy elements get distributed throughout galaxies, how gas gets pushed into regions where new stars can form, and how galaxies regulate their star formation rates. Beauty with purpose, art with function. Now let's witness one of the most intriguing structures discovered in recent years, the Red Square Nebula MWC 922. This protoplanetary nebula presents an almost perfect square when viewed from Earth, with such geometric precision that it seems artificial. Located about 5,000 light-years away, it represents a brief phase in stellar evolution, lasting perhaps only a few thousand years, making our observation of it remarkably fortunate. The The square shape likely results from two cone-shaped cavities carved by jets from the central star, which we happen to view exactly edge-on. The edges of these cones form the square's sides, glowing red from a combination of hydrogen emission and reflected light from carbon-rich dust. But within this square are more mysteries, a series of horizontal rungs like a ladder, each one possibly representing a periodic eruption from the dying star. Some astronomers have counted over 100 of these rungs, suggesting the star has been unstable for centuries. What makes the red square particularly fascinating is that it might preview our Sun's distant future. The central star appears similar in mass to our Sun, showing us what our star might look like as it begins its transformation into a planetary nebula 5 billion years from now. The carbon-rich chemistry suggests the star has dredged up processed material from its core, the ashes of billions of years of nuclear fusion now being painted across space in geometric patterns of red light. Let's journey to the constellation Sagittarius, where we find Messier 8, the Lagoon Nebula, a vast star-forming region so large and bright it's visible to the naked eye as a faint patch of light. Spanning 110 light-years across and located 4,000 light-years away, the Lagoon Nebula gets its name from the dark channel that winds through its center, resembling a lagoon cutting through a bright landscape. At the heart of the lagoon lies NGC 6530, a young cluster of hot stars formed from the nebula's gas just 2 million years ago. The brightest of these, Herschel 36, is a monster star 40 times the Sun's mass, blasting out stellar wind that sculpts the surrounding gas into fantastic shapes. This star alone emits enough ultraviolet radiation to ionize gas for light-years around, creating the nebula's characteristic pink glow from hydrogen emission. But the Lagoon Nebula isn't just beautiful, it's a stellar nursery in full production. Infrared observations have revealed over 100 protostars still forming within dark globules throughout the nebula. Some of these are in the process of clearing their birth cocoons, creating bright rims around dark clouds known as bright-rimmed clouds. Others are shooting jets of material that slam into surrounding gas, creating bow shocks that glow in blues and greens. We're witnessing star formation at every stage, from dark clouds just beginning to collapse to young stars already clearing cavities in their birth nebula. The lagoon contains one of the most remarkable single objects in any nebula, the Hourglass Nebula, not to be confused with the planetary nebula of the same name. This is a bright, compact region where hot gas is being twisted by magnetic fields and sculpted by radiation into a shape resembling a cosmic tornado. The structure is only half a light-year across but glows more brightly than regions hundreds of times larger. It's possibly the site of very recent star formation, perhaps a massive star just beginning to emerge from its cocoon. Now let me show you one of the universe's most delicate sculptures, the Veil Nebula, remnants of a star that exploded about 8,000 years ago. Located 2,100 light-years away in the constellation Cygnus, this supernova remnant has expanded to cover an area of sky 6 times larger than the full moon. But its filamentary structure is so intricate that it resembles lacework made of light, earning it the nickname the Cirrus Nebula for its resemblance to wispy clouds. The Veil Nebula is actually several distinct regions, the Eastern Veil, Western Veil, and Pickering's Triangle, all parts of the same expanding shell of gas. The explosion that created it released energy equivalent to the Sun's total output over billions of years, concentrated into seconds. The blast wave is still traveling at about 170 kilometers per second, slamming into interstellar gas and heating it to millions of degrees. Where this ancient shockwave meets dense gas, it glows in spectacular colors, red from hydrogen, green from oxygen, and blue from sulfur. What makes the veil particularly stunning is how different it appears in different wavelengths. In visible light, we see delicate filaments like cosmic hair. In X-rays, we see the million-degree gas that fills the interior. In infrared, we see dust grains being destroyed by the shockwave. The Hubble Space Telescope has captured portions of the veil in such detail that we can see individual knots of gas no larger than our solar system, each one a fossil of turbulence from an 8,000-year-old explosion. Let's explore something that demonstrates the universe's sense of humor, the Sombrero Galaxy, Messier 104. Located 31 million light-years away, this galaxy appears almost exactly edge-on from Earth, and its distinctive dust lane gives it the appearance of a Mexican hat floating in space. But this comical appearance hides one of the most unusual galaxies we've studied, a hybrid that doesn't fit neatly into our classification schemes. The Sombrero Galaxy is massive, containing 800 billion stars, about twice as many as the Milky Way. Its central bulge glows with the golden light of ancient stars, while its disk is traced by a dramatic dust lane that blocks the light from stars behind it. But here's what's strange: it has characteristics of both spiral and elliptical galaxies. The disk suggests a spiral, but the huge bulge and massive halo of globular clusters, over 2,000 of them, are more typical of ellipticals. It's as if two different galaxy types were merged into one. Recent observations have revealed the Sombrero's hidden violence. Its supermassive black hole, weighing 1 billion solar masses, is one of the most massive known in a nearby galaxy. X-ray observations show jets of material shooting from near the black hole, though currently the beast is feeding quietly. Infrared observations penetrate the dust lane, revealing a ring of star formation hidden from optical telescopes. The Sombrero might look serene, even humorous, but it's a complex system still actively evolving. Now let's witness one of nature's most perfect demonstrations of symmetry and violence. The planetary nebula NGC 6302, better known as the Bug Nebula but sometimes called the Butterfly Nebula for its distinctive shape. The wings of this cosmic butterfly stretch 3 light-years from tip to tip, glowing with gas heated to 36,000 degrees Celsius. But unlike its peaceful Earth counterparts, this butterfly was born from stellar death, its wings the death shroud of a star. The Bug Nebula's central star is one of the hottest known, with a surface temperature exceeding 200,000 degrees Celsius. This extreme heat drives one of the fastest stellar winds observed, electrons and ions racing outward at over 900 kilometers per second. Where this fast wind catches up with slower-moving gas expelled earlier, it creates shock fronts that heat the gas until it glows across the electromagnetic spectrum. The result is a butterfly painted in cosmic light, its wings displaying every color from red to X-ray. But the Bug Nebula holds deeper mysteries. Its perfect bipolar symmetry suggests the dying star has a companion, their orbital dance shaping the expelled gas. Hidden within the nebula's waist is a disk of dense gas and dust that blocks our view of the central star system. This disk acts like a cosmic corset, squeezing the expanding gas into the butterfly shape we observe. Some of the gas in the wings is enriched with neon, magnesium, and other elements forged in the star's final years, elements that will eventually become part of new stars and planets. Let's journey to the Large Magellanic Cloud, our satellite galaxy, where we find NGC 2070, the Tarantula Nebula's younger sibling, sometimes called the Seagull Nebula. This massive star-forming region spans over 300 light-years and contains some of the most massive stars ever discovered. But what makes it particularly beautiful is its layered structure, like looking at a cosmic wedding cake, where each layer tells a different story of star formation. The outer layers of NGC 2070 glow with the red light of hydrogen, excited by ultraviolet radiation from young stars. Moving inward, we find shells of green oxygen and blue helium, each element ionized to different degrees depending on its distance from the hot stars at the center. The very core contains a cluster of Wolf-Rayet stars, massive stars so hot they're literally blowing themselves apart, their stellar winds reaching speeds of thousands of kilometers per second. Recent observations have revealed that NGC 207 is experiencing triggered star formation on a massive scale. The first generation of massive stars, formed perhaps 5 million years ago, have carved cavities in the surrounding gas. Along the edges of these cavities, the compressed gas has formed a new generation of stars. These younger stars are now beginning to carve their own cavities, triggering yet another generation. It's a chain reaction of star formation that will continue until all the gas is either converted into stars or blown away into intergalactic space. Moving closer to home, let's explore the North America Nebula NGC 7000, which bears an uncanny resemblance to its terrestrial namesake when viewed from Earth. Located just 2,000 light-years away in Cygnus, this emission nebula spans about 100 light-years, so large that under perfectly dark skies, the entire nebula would appear 4 times the size of the full moon. The resemblance to North America is so striking that you can identify the Gulf of Mexico, Florida, and even Central America in its glowing gas clouds. The North America Nebula remained a mystery for decades because astronomers couldn't identify the stars responsible for making it glow. The answer came from infrared observations that penetrated the thick dust clouds. A monster star called Bayard's star, hidden behind the dark cloud that forms the Gulf of Mexico, is illuminating the entire complex. This single star, about 40 times more massive than our Sun, emits enough ultraviolet radiation to ionize hydrogen gas across hundreds of cubic light-years. What makes the North America Nebula particularly fascinating is that it's part of a larger complex, including the Pelican Nebula, separated by a dark molecular cloud. This dark cloud is where the real action happens. It contains hundreds of young stellar objects, protostars still gathering mass from their surroundings. Some of these baby stars are shooting jets that stretch for light-years, carving tunnels through the dark cloud. In a few million years, these new stars will emerge, completely transforming the nebula's appearance. Future astronomers might not see North America at all, but some entirely new shape carved by different stars. The nebula showcases beautiful color gradients that tell us about its physical conditions. The bright Atlantic coast glows intensely where the illuminating star's radiation is strongest. Moving inland, the colors shift from bright white blue to pink, and finally to dark red at the edges, mapping the decrease in ionization with distance. Some regions show unusual green emission from doubly ionized oxygen, indicating extremely high temperatures. It's like a cosmic heat map painted in the colors of glowing gas. Let's witness one of the most dynamic objects in our cosmic neighborhood, the Orion Nebula, Messier 42, the closest star-forming region to Earth at just 1,344 light-years away. Visible to the naked eye as the middle star in Orion's sword, this stellar nursery is perhaps the most studied deep-sky object in astronomy. Every major telescope ever built has observed it, and each new instrument reveals more layers of complexity and beauty. At the heart of the Orion Nebula lies the Trapezium cluster, 4 hot young stars that formed from the nebula's gas less than 1 million years ago. These stars, visible in small telescopes, are responsible for illuminating the entire nebula. The most massive, Theta 1 Orionis C, is 40 times the Sun's mass and emits more ultraviolet radiation than 10,000 Sun-like stars combined. This intense radiation has blown a cavity in the surrounding gas, creating what astronomers call the Huygens region, a bubble of hot, ionized gas that glows with an ethereal blue-green light. But the Orion Nebula is far more than just 4 bright stars. Infrared observations have revealed over 700 young stars still wrapped in dusty disks, solar systems in the making. The Hubble Space Telescope has directly imaged over 150 of these protoplanetary disks called proplyds, some showing jets and outflows as planets form within them. We're literally watching the birth of worlds that might one day harbor life. Some of these disks are being eroded by radiation from the trapezium stars, racing against time to form planets before their raw materials are blown away. The nebula's three-dimensional structure is breathtaking when revealed by spectroscopic studies. It's not a flat cloud, but a vast cavern in space, with Earth positioned near the opening looking in. The back wall of this cavern is about 30 light-years away, glowing with reflected and emitted light. Filaments and pillars stretch from the walls toward the center, each one sculpted by stellar winds and radiation. Some of these pillars point directly at the trapezium stars, like fingers pointing at their destroyer. Now let's explore one of the most enigmatic beauties in space, the Blue Horsehead Nebula, NGC 3579, a reflection nebula in Orion that showcases a completely different kind of cosmic beauty. Unlike emission nebulae that glow from ionized gas, this nebula shines with reflected starlight, creating an ethereal blue glow reminiscent of moonlight on clouds. The blue color comes from the same physics that makes Earth's sky blue. Smaller dust grains scatter blue light more efficiently than red. At the center of the Blue Horsehead sits a young, massive star still partially embedded in its birth cloud. This star, catalogued as HD 48099, illuminates the surrounding dust and gas, but isn't hot enough to ionize it completely. Instead, we see scattered starlight painting the cosmic dust in shades of blue and violet. Dark lanes of denser dust weave through the nebula, creating the pattern that gives it its equine nickname. Some astronomers see a horse's head, others see a completely different shape. Beauty is truly in the eye of the beholder. What makes reflection nebulae like the Blue Horsehead special is their transient nature. In perhaps just 100,000 years, the central star's stellar wind will blow away the dust, ending the light show. Or the star might evolve, becoming hot enough to ionize the gas and transform the reflection nebula into an emission nebula. We're seeing a brief phase in stellar evolution, a moment of quiet beauty before more violent transformations begin. Let's journey to something that defies initial explanation, the Retina Nebula, IC4 406, a planetary nebula that looks remarkably like a human eye complete with pupil, iris, and eyelid. Located about 5,000 light-years away in the constellation Lupus, this nebula showcases what happens when a dying star experiences multiple episodes of mass loss, each one creating a distinct shell of gas. The Retina Nebula's structure tells a complex story of stellar death. The outer shell, the white of the eye, formed perhaps 10,000 years ago during an early phase of mass loss. The inner shell, forming the iris, came later as the star's core contracted and heated up. The dark pupil in the center is actually a dust torus that blocks light from the central star in our direction. The whole structure spans about 1 light-year, and different wavelengths reveal different layers, like performing a CAT scan on a cosmic eye. Recent observations have detected molecules in the Retina Nebula that shouldn't survive in such a hostile environment: water, ammonia, and even some organic compounds. These molecules are shielded from destructive ultraviolet radiation by dense clumps of gas and dust. It's a reminder that even in death, stars create conditions where complex chemistry can occur. Some of these molecules will eventually be incorporated into new solar systems, perhaps contributing to the development of life. The universe recycles everything, even the molecules in a dying star's last breath. As we near the end of our cosmic journey, let me share one final masterpiece that brings together everything we've explored: the Rho Ophiuchi cloud complex, one of the most colorful regions in the entire night sky. Located just 400 light-years away, this stellar nursery is our nearest active star-forming region, a cosmic artist's palette splashed across 50 light-years of space. Every color tells a different story, every hue reveals different physics at work. The heart of Rho Ophiuchi glows with the blue light of young hot stars reflecting off surrounding dust. These stars, including the binary star system Rho Ophiuchi itself, are mere infants, less than 1,000,000 years old. Their intense radiation creates cavities in the surrounding gas, like cosmic snow globes with the stars as central ornaments. Surrounding these blue reflection nebulae are vast clouds of red hydrogen emission, where slightly older stars have begun ionizing their birth clouds. But the real magic happens in the dark clouds that snake through the region like cosmic rivers. These molecular clouds, some of the densest in our galaxy, appear as dark silhouettes against the glowing background. Inside these dark rivers, hundreds of protostars are forming right now. Infrared telescopes reveal these hidden stellar embryos as glowing red dots, each one a future sun, perhaps destined to warm future worlds. The James Webb Space Telescope recently peered into these dark clouds, revealing jets and outflows from forming stars that had never been seen before. What makes Rho Ophiuchi truly special is the variety of objects at different evolutionary stages, all visible in one region. We see dark clouds just beginning to collapse, protostars gathering mass, young stars emerging from their cocoons, and slightly older stars beginning to clear their surroundings. It's like having a time-lapse view of stellar evolution frozen in a single moment. The region even contains a few older stars that wandered in from elsewhere, their yellow and orange light contrasting with the blues and reds of their younger neighbors. Throughout our journey today, we've witnessed the universe's artistry on scales from light years to thousands of light years. We've seen stellar nurseries where stars are born, planetary nebulae where they die, and galaxies where billions of stars dance together in cosmic choreography. But here's what makes these objects truly beautiful. They're not static paintings, but dynamic sculptures, constantly changing, evolving, transforming. The pillars of creation are being destroyed even as we admire them. The Bubble Nebula is still growing. Galaxies are colliding, creating new forms of beauty from cosmic catastrophe. Each of these objects connects to us in profound ways. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were forged in the nuclear furnaces of dying stars like the ones that created the planetary nebulae we've explored. The organic molecules detected in the red rectangle and other nebulae might be similar to those that seeded Earth with the building blocks of life. We're not separate from these cosmic wonders. We're made from them, connected across space and time by the recycling of matter through stellar generations. The colors we've seen, the reds of hydrogen, greens of oxygen, blues of reflection nebulae, are the universe's way of revealing its composition and conditions to us. Each wavelength of light carries information across vast distances, allowing us to understand objects we'll never physically reach. When you see images from Hubble or James Webb, you're not just looking at pretty pictures. You're reading stories written in light, narratives of creation and destruction, birth and death, all painted in wavelengths our eyes evolved to perceive or that our instruments can detect. What strikes me most about these cosmic beauties is their impermanence. The Orion Nebula will be gone in a few million years. The Ring Nebula is already fading. The colliding Antennae galaxies will eventually merge into a single elliptical galaxy, their beautiful spiral arms lost forever. This transience makes them even more precious. We live in a brief cosmic moment when these particular forms of beauty exist. Future astronomers will see different nebulae, different galaxy collisions, different stellar deaths, creating new forms of beauty we can't imagine. Yet from this impermanence comes continuity. The gas dispersed by the Veil Nebula will form new stars. The elements forged in Eta Carinae will eventually become parts of planets. The organic molecules in the Horsehead Nebula might one day become part of living beings contemplating their own origins. The universe doesn't just create beauty, it recycles it, transforms it, uses it as raw material for new forms of cosmic art. As you go outside tonight and look up at the stars, remember that you're not just seeing points of light. You're seeing stellar nurseries, dying stars, distant galaxies, each one a masterpiece of physics and chemistry, gravity and time. The faint smudge of the Orion Nebula, visible to your naked eye, contains newborn solar systems. The stars of the Big Dipper are at different distances, their apparent pattern a temporary arrangement that will change over thousands of years. Beauty surrounds us on scales we can barely comprehend. These cosmic objects remind us that we're part of something magnificent. Every atom in your body except hydrogen was forged in stellar cores or during stellar explosions. You're not just in the universe. You are the universe, contemplating itself. When you admire the beauty of a nebula, it's the universe admiring its own handiwork. We're stardust that has evolved to the point where we can understand our origins, appreciate beauty, and share that wonder with others. The most beautiful objects in the universe teach us about more than just physics and chemistry. They teach us about time, how brief our lives are compared to cosmic processes, yet how fortunate we are to exist at all. They teach us about scale, how vast the universe is, yet how intricate its smallest details can be. They teach us about connection, how everything in the cosmos is related through the exchange of matter and energy across space and time. So the next time you see an image of a nebula or galaxy, don't just admire its beauty. Think about the story it tells. Consider the forces that shaped it. Marvel at the fact that you can understand what you're seeing. And remember that you're made of the same stuff, shaped by the same forces, part of the same cosmic story. The universe's most beautiful objects aren't just out there in space, you're one of them, a collection of atoms that can appreciate beauty, seek understanding, and share wonder. Thank you for joining me on this journey through the universe's greatest masterpieces. If this exploration has changed how you see the cosmos, please share it with someone who needs more wonder in their life. Subscribe to continue exploring the magnificent universe we inhabit. And remember, every time you look up at the night sky, you're seeing beauty that took billions of years to create, captured in light that traveled vast distances just to reach your eyes. And if you enjoyed this video, I am sure you're going to love this other one at the left side of the screen. What is the largest thing in the universe? In this video, we journey from Earth to the edge of the observable universe, exploring galaxy clusters, the cosmic web, superclusters, vast cosmic voids, and much more. See you there.